All right, so we're looking at rates of change again, and here I'm just going to focus on the Coos County. So I'm going to, let's see, make a copy of this so I don't mess it up for anyone else. Please.
Oh.
All right, and then I'm just going to get rid of a bunch of other stuff here because I only want that. Okay. So Coos in the beginning of May last year had 30 cases, and then in the beginning of August, they had 90 cases. And what I want to do is I want to use that to find the rate of change, the slope, and then make a prediction for January. So with anything like this, I often write stuff down on paper, even if I am using a spreadsheet. So my paper version for Coos County COVID data. This is total cases. We've got, I'm going to make 3 columns here. I'm going to put the month here, and then what I'm going to call the month for the X value, and then Y is going to be the total cases. So in the month of May, which is my starting month, my 0 month, they had 30 cases. And then in the month of August, which, let's see, May, did I get that right? May, June, July, August, that's 3 months later, counting on my fingers, and I highly recommend counting on your fingers, things like this, we jumped up to 90. So a review back to the previous course, for those of you that took Math 62, if I want to find the difference in cases, that's what we call an absolute change. And that would mean to find out how far 90 and 30 are. So we can look at this and see, oh, look, the cases went up, but by how much did they go up? So that's the change I want to find. So that would just be 90 minus 30. That's 60. So I can see, all right, they went up by 60 cases. So up by 60 cases. Now, we're going to take a little bit more information into account here. That happened over 3 months, right? So this is over 3 months. So if someone said, okay, well, about on average, how much is that per month? Okay, so if I wanted to know total cases per month, I just take the change in total cases, that's my 60, oops, and divide by the months that the time that went by, and that would be 3 months. So Coos is kind of nice, 3 goes into 60, comes out to a nice number, 20. And I mentioned in the last class and in the video that it doesn't always come out that nice. And the rounding rule for things like this in math is if you have to round in a situation like this, look at the numbers in the data set and then go 1 extra place. So if I had to round, I would call it 20.0. And some of you did that in your assignment, some of you didn't, and I made a note about it if you didn't. Not a huge deal, but just something to think about. So this right here is what we call the rate of change. Units are cases per month. So the big things we're looking at here is this idea of a rate of change, which compares the absolute change of 2 things, in this case, cases and months. 60 cases went by over 3 months. 60 divided by 3 gives me 20 cases per month. This idea of cases per month here is also what's called a unit change. And the word unit refers to the idea of 1. So whenever I have a rate of change, a rate is a fraction. So to write 20 as a fraction, I would call it 20 over 1. But dividing by 1's kind of boring, we usually don't do it and just say, well, why don't we just call it 20? That's simpler, okay? So if definitely the rate of change is 20, but 20 what? It's 20 cases every 1 month. Okay? And so when I carry out this division, that gives me what we call a unit change or a unit rate. Now, next thing we do with stuff like this is we try to make predictions with it. And to make a prediction, I need some kind of model. And a model is usually an equation. But it could be a picture or a table of numbers. And the type of equations we're playing with right now look like y equals mx plus b. Let's see, my doorbell just rang. Let's see who we got here. All right, Cody, welcome, Cody. Glad you could join us. So reminder about this, the m right here, that's our rate of change. We also call the rate of change the slope. B is starting point. It's also known as the y-intercept. And when we look at something like a y-intercept is a point. And if I plugged in x equals 0, then the mx disappears and I just get the b. So it's the point 0, whatever b is. And if we look back at my table for the COVID numbers for Coos County, back here, we can see my y-intercept right here. It's the point 0, 30, right? X is 0, y is 30. That's my starting point here. So for the Coos County data, County COVID, I could say that y equals 20x plus the starting value of 30. And a reminder of what my x and y are, y is the total cases in Coos County. And x is the number of months after May. And every week, every day in this class, we're going to be coming up with these new models, these new equations. And every time we do that, we do want to make sure we define our variables. We say, hey, what does this letter mean? What does that letter mean? And sometimes we'll use better letters like maybe C for COVID and M for months or T for time. So we also want to pay attention to that too. But regardless of the letter, we should say, what the heck does that letter mean? So my hope was that you did something like this on your share your work, and everybody did graded something like this, and it looked really good. If you didn't check out the feedback I left, go check it out soon. So I'm not quite done because I didn't do my prediction yet. So the next step, I was asked to do a prediction for January 2021, and I'm good at math, but dates kind of throw me. I can't remember when something happened in time exactly. What year was that again? And I always have to count on my fingers for months to figure out when something's going to happen. So I had to count up to January. Sometimes I even have to look at a calendar. So I'm trying to get from May 2020 to January 2021. And I could show you counting on my fingers, or maybe I'm just going to write some letters here. So after May, right, that's June, then July, August, what's next? September, October, November, December, and then I finally get to January. May, June, July, August, September, October, November, December. I don't think I missed anything. 1, 2, 3, 4, 5, 6, 7. That would be 8 months later. And so that means for my prediction in my equation, I gotta let x equal 8. So then I go back to my equation, y equals 20. Instead of an x, I'm going to put the x equals 8 in there, add the 30, and depending on your numbers, you needed a calculator or not. So let's see, 20 times 8 is 160 plus 30. So I can get away without a calculator here because these numbers aren't too bad. The prediction is that there should be 190 cases. So I could say something like, if the trend from May to August continues, then there will be about 190, whoa, extra zero, 190 total cases of COVID-19 in Coos County. So now I'm trying to get to that writing principle. I talked about we want to give a reasonably descriptive sentence that states what the number means. So if I just said, hey, there's going to be about 190 cases, you're going to be like, huh? 190 cases? Where? When? So did I do a good job? Let's see. If the trend from May to August continues, there will be about 190 total cases of COVID-19 in Coos County. When, Gary? Oh, in January. Right. Oops, forgot that part. So often I have to make multiple drafts of my sentences. In January 2021. Okay. So that's most of that assignment right there. And I did something like this in the video and in class last week. The other thing was to do this on a spreadsheet. So back here, I started making my paper version of the spreadsheet table. And I'm going to add to that right there the slope calculation in my spreadsheet, and I'm going to add this prediction to my spreadsheet. So just a little more work with spreadsheets. So as far as the slope went, that calculation took me 2 parts, right? I had to find the difference between the 2 numbers I was given, and then I had to look at the change in months. And usually if there's a multiple stages to a mathematical calculation, you need parentheses. And I showed this in the video in the last class, equals to do a calculation. If I want to do the slope in one shot, I need parentheses to take this 90 and subtract that 30, and I just click on where they're located. I close the parentheses, and then I can divide by the 3 months that have gone by. And there's the 20 that I wanted for the slope. For the prediction for January, I'm just going to make a note up here that x equals 8 for that, because it's 8 months later. And a lot of times in the spreadsheet, I put notes to myself to make it more readable when I look back at it. So x equals 8 months later. And then the calculation down here is just to go equals, and it was my slope 20 times, I have to actually type the 8, and then I can add on the 30 that's already here on the spreadsheet. And if I hit enter, that should confirm the calculation I tried to do on paper, and there's the 190 cases. So if I were turning this in, I would turn 2 things in. I would turn in a copy of this spreadsheet, and then I would turn in a picture of my notes pages. And so essentially, aside from my lecturing here, I have 1, 2 pages. I guess I need that middle page too, because it tells what x and y are here. That's important in the actual equation. But on a regular piece of paper, I probably could have fit this on 1 page. And so that's what I would turn in there. So what's the point here? The point's a couple things. If we're given some data, we can try to see if there's a pattern to it, or just assume there's a pattern. COVID cases are going up. I'm going to guess that this equation might show me how they're going up. Now, it is January 2021, right? So we could look up the data and see, and it turns out in that spreadsheet that I originally shared here, you might have noticed there was a second tab down at the bottom, a second sheet that said 2021-01-10. So last week on the 10th, I went to the Oregon Health Authority website and looked up the data, and these on the 10th were the total number of cases. So here it says Coos County last week was at 863. I predicted that they would have 190. So here's the question. I said, if the trend continues from May to August, did the trend from May to August continue, or did the trend change?
Changed.
It definitely changed. Now, some counties, they didn't. Some of the counties, it stayed about the same as May to August. People maybe were social distancing then, and they continued to do a good job of it in that county. In other counties, they did a shitty job in May and August and continued to do a shitty job in January. Just kind of, every county was a little bit different, I found. Overall, what I discovered, though, is that the May to August trends, if we continued it to predict January, underestimated January drastically, is what I found. So if I just do that on the total for Oregon, you can see what I mean. So these are the totals here. And let's highlight that. So the slope here, just like before, would be equals parentheses, take the second number, subtract the first number. That'll show how much the cases went up. And then if I want the monthly change, I divide by 3 because 3 months went by there. So overall, cases in Oregon between May and August were increasing by almost 6,000 new cases per month. If I then try to predict into January, I do the same idea. I take that monthly prediction, multiply it by 8 months, and then add that in May we started with 3,228. So this would give me a prediction for Oregon. Let's drop some decimals there to make it more readable and throw in some commas. Where's the comma button? Right there. Okay, so this says, okay, if the trend from May to August continued, there'd be around 50,000 total cases in Oregon. The health authority last week said there were, what's that, 120,000? 120,000, so more than double the amount than the trend that started in May and August. Okay, now May and August are summer months. It didn't spread as fast when people were outside, but then all of a sudden fall and winter hit, people are inside more, and that gave more opportunity probably for the spread. There's probably other factors there too. So was this change a straight line? The answer is no, it was kind of wiggling in a curvy way upward if we looked at all the data. And every week we're going to continue to play with some interesting data sets and see what trends continue and what trends don't in a line kind of way. All right, next, let's see where my notes go about what we're doing today. I think next we need to look at a weight loss program. Okay. So let's pause.